Okay, we're going to talk about 1.4 in Algebra 2 Honors. We're doing 3 to 45 odds. And most of it is factoring. You're factoring, a lot of them are trinomials, ax squared plus bx plus c. I always find a times c. So if we can find a times c, what would that be? 2 times 3 would give me 6. List all the factors of 6. 6 times 1, negative 6 times negative 1. 3 times 2, negative 3 times negative 2. Then I also want to know what b is. B is 5. Any questions on finding a times c or b? There are different methods of factoring. If you have a method that's working, I don't want to change you. But if you want a method that works well, follow this if you can. How do you get 2x squared? There is only one way, 2x times x, right? 2x times x. Unlike number 5, how would you get 4r squared? Well, it might be 4r times r, or it might be 2r times 2r. 2 is a prime number, kind of, so it's really, there's only one way to do it. 4, on the other hand, is not. So anyway, I want to find things that multiply to 6, so I wrote all the things that multiply to 6, and I want to find anything that adds to 5. I think the ones that add to 5 would be 3 and 2. 3 plus 2 is 5. Now, what you do is you connect the outsides. That's not very visible. Let me use a different color. About a dark purple. Okay. You connect the outsides and you connect the insides. This number 2 goes into which of these over here? Does it go into the 3 or the 2? Evenly. It goes into the 2. So I'll put the 2 there and I'll put the 3 here. Now I think I go 2, let me use a different color. 2 times what equals 2? I'll say it again. 2 times what equals 2? That would be a positive 1. There's a 1 here. 1 times what is 3? 1 times what is 3? Well, it would be a positive 3. Now I'm going to rewrite it. 2x plus 3 times a quantity of x plus 1. And hopefully, if last times last equals last, I would say 1 times 3 equals 3. We should have it factored correctly. Let's do number 5. What's a times c on 5? 4. There's not too many factors of 4. 4 times 1, negative 4 times negative 1. 2 times 2, negative 2 times negative 2. What's b? 5. I'm looking for something that adds to 5. How about 4 and 1? Do they add to 5? So, does 4 go into one of these evenly? 2 goes into 4, but does 2 go into 1 evenly? No, so I don't think it's that one. I'm going to connect my outsides and my insides. 4 goes into the 4, so I put the 4 with the 4 and the 1 here. Okay, 4 times what is 4? 4 times what is 4? Positive 1. There's a 1 here. 1 times what is 1? 1 times what is 1? Positive 1. So again, we should have it factored. 4r plus 1 times r plus 1. Make sure again, does last times last equal last? 1 times 1 equals 1, right? For number 11, I have a, b, and c. What is a times c? 11 times negative 9 is negative 99. What is b? b is 2. So how can I get negative 99? Negative 99 times 1, 99 times negative 1. I do notice that 11 times negative 9 and negative 11 times 9 Do any of these add to equal 2? 11 minus 9 is 2. To get 11z squared, you'd have 11z times z, giving me 11z squared. Connect your outsides, connect your outsides, connect your insides. The 11 goes into the 11, so I put the 11 with the 11. 11 times what is 11? I'll say it again. 11 times what is 11? Positive 1. 1 times what is negative 9? 1 times what is negative 9? Well, I think it would be a negative 9, right? So that should be factored. 11z minus 9 times the quantity of z plus 1. Again, if you want to check last times last equals last, I think it does. Okay, 4y squared. 4y squared might be 4y times y, or it might be 2y times 2y. What is a times c on this one? Negative 16, and b is negative 5. So I list all my factors of negative 16. Negative 16 times 1, 16 times negative 1. Negative 8 times 2, 8 times negative 2. Does 3 go into 16? No. 4 times negative 4. Do any of these add to equal negative 5? So I don't believe this is factorable. Not factorable. Because there is no values that multiply to negative 16 that'll add the negative 5. At least I can't think of any. That's why sometimes you need to write out an exhaustive list. Okay, number 13. Now we're getting into a different form. These are difference of squares. A squared minus b squared is going to factor into a plus b times a minus b. The reason I'm saying that is these are both perfect squares. 3x quantity squared is 9x squared, and 1 squared is 1. So let's fill in what's a, what's b. A in this case is 3x, mainly the square root of that first part. Plus and minus b, b happens to be 1. So this would factor to 3x plus 1 times 3x minus 1. The difference of squares. Are these perfect squares? What squared gives you 49? Could that be 7n quantity squared? 16, could that be 4 squared? So you're going to have 7n plus 4 and 7n minus 4. Again, the difference of squares. What I'm doing is I'm using this formula up top here. Okay, if I go to 17, I notice that that's a perfect square and that's a perfect square. So I see the square root of 49x squared is 7x, the square root of 25 is 5. And what's that first sign? I believe it's a plus. So there's my answer if you get good at these. But let's try them, because when you do a times c on this, what's a times c? It's a huge number because you got 49 times 25. And you start writing factors of those, it's going to get pretty hard. But let's check this, make sure it works. 7x plus 5 times 7x plus 5. Would that give me 49x squared? Would that give me 35x and another 35x, which is 70x? And last times last is 25. So I think we have it correct. Now, how are you going to do number 33? I'm going to do it a couple ways. I'm going to do the proper way first. Can you factor an 11 out, leaving me q squared minus 4? Those are both perfect squares, right? So you get q plus 2 times q minus 2. I can make this equal 0. That would be q equaling negative 2. I can make this equal 0, and I solve it, I get q equals 2. Is there a letter in 11? Is there a variable in 11? Can 11 equal 0? 11x, yes, but 11 is not going to equal 0, is it? So that's why you really only have these two answers. Now, a lot of people are going to take the short way. You're going to add 44. You're going to divide by 11. And then to get rid of a square, you take the square root. But a lot of you will forget to put a plus or minus. If you take a square root and you see an equal sign in an equation, you have to put plus or minus. Okay, 33. How about 35? I watch 35 very carefully, please, because a lot of people struggle with these. Is there something that divides into 45 and 10 evenly? 5. So I'm going to factor a 5 out. Now I look at the ends, end of the second and end of the first. Which is a smaller power? End of the first. So that's what I'm going to factor out is a 5 end of the first. There's a plus here, and this thing equals a 0. 5 times what is 45? 9. And do I need another n to make the n squared? I'm sorry, I just need the n to make the n squared, right? Okay, 5n times what is 10n? 2. So I have 5n times 9n plus 2 equals 0. I'll make each factor equal 0. If 9n plus 2 equals 0, I would subtract 2 and then divide by 9. So one of my answers is negative 2/9. How about if 5n equals 0? How do you get rid of the 5? What's the opposite of multiplying by 5? Dividing by 5? 0 divided by almost anything would be 0. So we have two answers, 0 and negative 2/9. These are solving. You'll notice 35 and 39 have their equations. They equal 0. So did 33. It had an equals also. It was an equation. These are the ones where you can actually solve. So how do you get 6n squared? There's only two choices. 6n times n. Oh, I'm sorry, r's, you're right. 6r times r, or it might be 3r times 2r, which would also give me 6r squared. Okay, I'm going to make a little room, so I may erase some of this stuff. What is a times c on number 39? A times c, 6 times negative 5, I believe is negative 30, and b is negative 7. With practice, you'll go right to them. What multiplies to negative 30 and adds to negative 7? Negative 10 and 3. Does 6 go into either of those evenly? Does 6 go into 10 or 3 evenly? No, so you can't use that approach. Does 3 go into 3? And does 2 go into negative 10? So this is the one I want. 3 goes into which of those numbers? 3 goes into the 3, so I put the 3 with the 3. 2 goes into negative 10, so I put it down with the 2. Now again, we have to think. 3 times what is 3? I'll say it again. 3 times what equals 3? That would be a positive 1. Let's do this one. 2 times what is negative 10? 2 times what is negative 10? That'd be a 2 times negative 5 would give me negative 10. Now I have to make each factor equal 0, because if something times something equals 0, one of these factors must equal 0. It's called the zero product theorem from Algebra 1. So basically I'm taking each factor and making them equal 0. Add the 5, divide by 3. Subtract the 1, divide by the 2. So there should be two answers. You may notice the power or the degree of this polynomial is 2. That's the maximum number of solutions, or zeros. These are zeros because it's making it equal 0. Okay, I'm going to move on. 39, then to 41, we want to find zeros. To find zeros means you make it equal 0. How do you get 4x squared? Well, it might be 4x times x, or it might also be 2x times 2x. We'll find out which it is by doing the AC and things. A times C, 4 times negative 5, negative 20. B is negative 19. It's got to add to that and multiply to that. So how about negative 20 times 1? Do they add to negative 19 and do they multiply to negative 20? Now, does 4 go into 20 and does 1 go into 1? So I would think it's this first one. 2 goes into 20, but does 2 go into 1 evenly? No, so it's really not the bottom one. So I'm going to connect up here my outsides and my insides. They used to call them the means and the extremes. Okay, 4 goes into which of those? The negative 20. So I put it up here. And there's a 1 there, so I put the 1 down here. 4 times what is negative 20? 4 times negative 5 is negative 20. 1 times what is 1? 1 times 1 is 1. Notice that last times last equals last. So what I'm going to do is I'm going to take each of these factors and make them each individually equal 0. So 4x plus 1 equals 0, or x minus 5 equals 0. If you simply add 5, you'll have one of your answers. If you subtract 1 to isolate the variable, divide by 4 to isolate the variable, you would have negative 1/4. So I hope we should have two answers here. Okay, on to another one, I think 43. Again, we're finding zeros, which basically just means make it equal 0. A times C, that would be 5 times negative 18, 50 and 40. I think that's 90, negative 90. What is B? Negative 27. So we need it to multiply to negative 90. It's got to multiply to negative 90, and it has to add to negative 27. So let's try some. Negative 90 times 1, 90 times negative 1, 45, negative 45 times 2, 45 times negative 2, negative 30 times 3, 30 times negative 3. Have you found one that adds to negative 27 yet? Yes. Right there, I think, right? Negative 30 plus 3 is negative 27. Now we're lucky, 5 is prime, so that's 5x times x would give me 5x squared. 5 goes into which of those numbers? I think the negative 30, right? And 1 goes into the 3. So we're going to go through it. 5 times what is negative 30? 5 times what is negative 30? 5 times negative 6, right? So I put negative 6. 1 times what is 3? 1 times what is 3? I think it would be a positive 3. Double check. Last times last equals last. 3 times negative 6 is negative 18, right? So I have to set each of these equal to 0. X minus 6 is the easier one. You just add 6 and you have one of your answers. 5x plus 3 equals 0 is a little harder. You have to subtract 3 and divide by 5. So if I was to opposite of multiplying by 5, divide by 5, you'd have negative 3/5. So again, there's two solutions here. I hope these help. Good luck.